In this video, I'm going to be doing the measurement functions, and once again, as I pointed out, this is a combination of several parts of the original comparison between the Siglent SDS1000 and the Rigol DS1000. So I just thought I would shoot a little introduction to explain that one of the problems that I kept having with that video or these videos was that I wasn't able to get a good focus and other things. And once again, I'm a complete amateur on YouTube. So at the time these videos were originally made, I was not using a tripod. I later learned from one of my viewers that it's a whole lot easier to read when I use a tripod. It doesn't bounce around all over the place. And I also got a little better, I think, at being able to focus the camera that I use. So at any rate, I hope you'll forgive the shaky hands and the poor focus of these videos. I was trying to show some things, and sometimes I was so focused on getting the words I wanted to say and the picture I wanted to show that I wasn't paying attention to how bad the quality of the video was. But once again, I hope you'll forgive that, and I hope you'll learn something from this combined section, which is really the second of the combined videos, but it's labeled as part 4 because the first video was the combined parts 1 through 3. Moving on now to measurement, and I'll tell you what I'm doing up on the screen there in a second. There are a variety of ways you can measure things on an oscilloscope. You can use cursors in the X direction to measure amplitude, or in the Y direction to measure time. Many scopes, including the Rigol and the Siglent that I'm looking at here, have automatic measurements. Those measurements sometimes work on a single channel, and in a few cases work on 2 channels, usually when you're measuring phase or delay. They often have an all measurement automatic function, which basically does all of the measurements. Now, generally the all does not include 2 channel, it's usually just on 1 channel. Don't forget that you also might have a pass-fail on your scope. So I'm not going to look at pass-fail. That's normally more of a production line function. But I am going to look at the use of a math function to help you with measurements. And that's what I'm doing up here. What I've got is I've stopped the scope in the, maybe this will be easier. I've stopped the scope, and I have the math turned on with the source. Source A is channel 1, source B is channel 2, and what I'm doing is I'm just adding those 2 channels. Down at the bottom you see channel 1 in yellow, channel 2 in the purple, or I think they call it red, but it's really more of a purple. And then up above you see the math function. And the reason that I bring this up is a lot of people are just never think about the fact that sometimes you can use things like the math function to tell you where you might have some problem areas. So if you look at the top screen, you'll see that it's the sum of the 2 at the bottom. The areas of interest are often those little spikes. What that tells you is that there's a brief period of time when both of those channels are high. There also is over here a brief period when both of these are low. Now, if you look at that on the screen, you might think, well, no, those change at the same time. Well, there's, of course, no such thing as simultaneous time. Let's look at some of the math functions that the 2 scopes have. And most scopes these days have algebra math, as does the Rigol and the Siglent. Add, subtract, multiply, divide, and square root. They often also have functional or calculus derivative, integral, etc. In the case of the Rigol, it also has log and len, log being the base 10 and len being base e. It also has exponential functions. In other words, you can raise e to a power. The Rigol also has and, or, not functions, which can be really useful, particularly if you're using the MSO feature, that is the mixed signal feature that connects there. In part because that's not, I don't have a Siglent that has an MSO capability. I'm going to save that for maybe a future video and not in this series. But those can be very useful, the and, or, and not functions. The Rigol also offers an absolute function and a really useful f of x function. F of x is a generic mathematical operation that allows you to create combinations of math functions. I won't go into it here. Maybe if there's somebody that really wants to look at that, I might show them how that might be useful, but I will tell you it's a very useful function. In the FFT area, which the scopes usually put under the math function, both of them have FFT. They both offer a split screen. They both offer cursor measurements. The windowing function, the Rigol offers 6 different windows, whereas the Siglent offers 4. They both allow you to scale either by dB, decibel, or in volts RMS, root mean square. I want to point out 2 things you might want to keep in mind. When you're doing math functions, you can eliminate a lot of noise in the signal using the average acquisition mode. The reason that's important is, particularly when you're using the derivative function, you really need to average your acquisition rather than using the normal or the peak modes. And finally, you can eliminate DC error in the FFT by using AC coupling in the vertical channel. So let's now turn to the math operations, and I'll just show you a few of the simple ones up here on the Siglent. So, as I was showing earlier, I have waveforms on the 2 input channels here and the math at the top. This is a math operation of plus. If we change that to minus, you see what happens at the math, which is in white, and basically you can sort of figure out what's going on here. It's just subtracting one from the other. Then if we go to multiply, you see it's multiplying the 2 together. And finally divide, and you see what's happening with the divide. It's really going off scale, and the reason is that when you divide a small number into a large number, the large number gets even bigger, and it kind of drives it off scale. I'm not going to bother with this. You don't use the division operation that often, but one thing that I'm going to skip the FFT for now and go straight to the integral function. And the reason I'm going to go to that is, in this case, the source is channel 1, so that's the yellow. One place where this integral function can be useful is in, if you will, predicting the output of, say, an op-amp in slew mode. Now you can actually measure the output of an op-amp in slew mode by hooking one of the channels up and doing the derivative of the output. So if you have the input on one channel, the output on another channel, and you do the derivative of the output, that will actually give you the slew rate in volts per microsecond or volts per second, etc. So those are some of the useful functions for the math operations. Now I'm going to stop at this point on the Siglent, and then when we get to the Rigol, we'll look at some of the additional math operations. I've switched over to the Rigol, and I have them side by side here now. Basically the same thing. The only difference really between the two is here I'm using channels 1 and 3 rather than, of course you don't have that option with the Siglent only having 2 channels. One advantage of using 1 and 3 is the acquisition modes. The channels 1 and 2 share the same internal channel, and basically it just switches between the two. So if you're sampling at a giga sample per second or whatever you're sampling at, if you turn on channel 2, then the channel 1 sample rate goes to half of what it was, and that's the same for channel 2. Whereas if you use channel 3, you get you get the full sample rate. So that's one advantage of a 4-channel scope. The other, although minor, advantage is that the displays are basically use the same colors, that is red and yellow, same as over here. Though I think on this camera the red at the bottom often looks kind of blue, but it's supposed to be a red. You see there's the colors on the scope. So this is the math function with the addition, and I won't go through the basic functions again, the basic algebra functions, but I will show you something I noticed that's kind of interesting. Over here, if I do a run stop, the display comes back completely synchronized and so on, and I have it in normal mode. I'll show you that. It's in normal sample mode over there, and when it stops synchronized. Over here you'll notice that it's in the normal mode. When I do a stop, you notice that it stops the bottom waveform, and the math waveform stops, but this one doesn't seem to want to synchronize. And what I noticed is if I move the mode button, then it will synchronize channel 1 again. Now understand, I'm triggering on channel 3, so I don't know what's really going on there. I will tell you that I don't have the latest firmware in this one, partly because I was worried that if I install it, it might mess up my my trial licenses. So at any rate, that is the algebra operation on the Rigol, and now I'll set up to do some of the other operations that this unit has that the Siglent does not. I've set up the Rigol for an absolute value function. On the bottom is just a sine wave, and at the top you can see is the absolute value. Now of course, basically this is the equivalent of a rectifier. The absolute value is the value away from 0, so of course it's always in the positive direction. Well, let's try the integral. And what the scope is showing us is what we learned in basic calculus, which is the integral of a sine wave is a cosine wave, and vice versa. So I don't think I'm going to do very much more with the math operations here, because I'm not sure this is something that you generally might use. Instead, I think what might be useful is to skip the FFT and go on to the next section, which will be on measurement using cursors and auto measurement. Here is the Rigol set up to measure all of the parameters. It can do 33 of them, of what it can do, mins and maxes, peak to peak, and so on. Basically, it's they're the same as the Siglent. The Siglent measures 36 parameters instead of 33, but I don't really think there's a tremendous difference there. One thing you can do is you can turn on the region key up here and select cursors. So right now you'll notice that there's a cursor on the left over there and another cursor on the right. Unfortunately, they only show up briefly when you're moving them, but it allows you to restrict the range of the automatic measurements. Normally it's the entire screen when that is set to screen, but you can restrict it to a smaller area if you want to. We'll do some measurements now on the Rigol. Before I do the cursor measurements, I thought I might show you the Siglent has pretty much the same feature. When you push the auto setup button, the scope goes into an auto measurement mode, and you may notice over here a sequence of several. This is for a single cycle, and if you push that, it goes to a single cycle. If you push the multi-cycle, it increases the number of cycles on the screen. So basically there are three time bases, if you will, after auto. One is try to get just a single cycle of the waveform. The second is sort of the default, that is a few cycles, and then the third is the multi-cycle. You can also measure rise time, and it will adjust the display to get a more accurate rise time measurement. Or the one problem that I have found is, unlike the Siglent, it's not apparent to me how you switch back to the original auto menu without pressing auto again, which of course consumes quite a bit of time. On the Siglent, this menu appears and stays there so that it's on the bottom. One other point that I'll talk about when I talk about cursors, this unit also has a hardware counter, and it appears right up here, and it blocks the waveform display a little bit, particularly when you're trying to display a couple of waveforms, so you have to move one up a bit. It would be nice if it actually would appear either up in this range or down in this bottom area, perhaps over here. But it does work well. It's just that it obscures the waveform display. Once again, on the Siglent, it doesn't do that. On the Siglent, it's down in the corner here, and it's below the waveform display. So let's go to cursors now. You may notice there's a mode. We're going to set manual. And when manual mode is selected, you notice that a window appears here that shows the various things you can measure. I'm going to move the waveform down a little bit. So let's zoom in on that and I'll show you what it's looking at. At the top is the X offset, then the Y offset, and the A refers to the A cursor, which is the solid cursor in this case, this one. The dotted line cursor is the B cursor. And so the next set are the location of the X of the X direction of the B cursor and the Y offset of the B cursor. Then the difference on the X axis between the B and A cursor, and then the difference between the B and Y cursor, and then you notice a 1 over the difference, that is the dx value. In other words, the bx minus ax value 1 over. So that the bx minus ax, of course, is the period of the signal, and the by minus ay is the amplitude difference of the signal. So 1 over dx is the frequency. So now let's see how you use cursors to adjust. The over on the right, you see there's a select, and the select you can push to select either the X or Y cursors. So let's use the X cursors first. We'll move this one here. Then we will go from cursor A to cursor B, and we'll move cursor B to there. Now let's set the Y cursors. Once again, you select the cursor A, and then you select cursor B, and there you can see BY is set to minus 50 millivolts and AY is set to 3.32 volts. The difference between the two, that is BY minus AY, is 3.3 volts. This is a 100 kilohertz signal, so if I had the cursor set real accurately, the BX minus AX value would be exactly 10 microseconds, and the 1 over dx would be exactly 100 kilohertz if this were an exact standard, which it's not. So let's move on now and do some auto measurements. I've now turned on the counter, which I noted earlier is up in the upper right hand corner here, and you may notice that it is measuring the frequency. This is once again a 100 kilohertz signal, approximately. It's not a frequency standard. And then I have enabled measure this button. Over on the left side are the measurements that you can make, and you can switch from the horizontal menu to the vertical menu with the menu button. The horizontal button, I have pressed the period, the frequency, and the rise time. You can have, of course, others. They appear down here, and these are the auto measurements. Remember earlier, the cursor measurements appeared in a little box in the upper left-hand corner. The auto measurements appear down here, and see if we can get that to focus. There we are. The period, 10 microseconds. Frequency, of course, of that is 100 kilohertz. And you may notice that jumps around quite a bit compared to the hardware counter in the upper right-hand corner. And the rise time. Now you can select a series of these. If you push one that's already selected, like the frequency, you'll notice that a selected item appears for a brief instant to show you that you already have that one. The reason is you can only have 5 measurements. So let's add fall time. You see there it appears at the bottom. And then we're going to include pulse width there. Now I'm going to include negative pulse width. And you may notice that when I do, negative pulse width appears here, but over here the period disappears. That is, everything slides to the left and only the most recent 5 buttons that you've pushed appear at the bottom. So that's how the auto measurement works. Obviously you can make measurements on the vertical as well. For example, if you want to look at the maximum voltage, that's this top key. And if you look down here, Vmax appears as 3.5, roughly 3.5 volts. Similarly, if you want to look at Vmin, you push that one, and Vmin appears. Once again, everything appears on the right, and all of the measurements to the left slide off. So in other words, you can do 5 measurements, combination of vertical and horizontal, in the auto mode, and have them displayed all at the same time. Okay, now let's look at delay and phase measurements. These are 2-channel measurements, so you have to specify a source 1 and a source 2. Now the Rigol comes up normally with the source 1 being channel 1 and the source 2 or source B being channel 2. I've changed it to channel 3 here once again because I like to use 1 and 3 instead of 1 and 2 for basic comparison measurements to help speed up the acquisition rate, but you can use 1 and 2 if you want, in which case you may not have to change these when you go to a delay measurement. So as I pointed out, when you go down to the bottom menu and scroll to the bottom, the menu over here appears, and you select delay. I'll select delay 1 to 3 falling edge. That's first one is rising, falling. Phase from 1 to 3, and phase from 1 to 3, once again rising and falling edge. And down here you'll notice that the delay from 1 to 3 is moving around quite a bit, and the reason is that the scope is not stopped, so it's updating, and the bottom trace is a random pulse width. So I will stop it, and as you may remember from an earlier video, when you stop it, to get the trace to synchronize, for some reason you have to change the mode. Once it synchronizes, now you'll notice you'll notice when it focuses that we're now getting a pretty stable delay of about 960 nanoseconds. No delay from 1 to 3 on the falling edge, and the reason is that if you look at the waveforms, you'll see that the rising edge is here, and there is a delay there. There is not a delay between this falling edge and this signal. They are the same, and that's the reason why you get there. By the way, you can eliminate some of that ambiguity by just changing the trace display. Now you see the delay from 1 to 3, the falling edge is 0, The phase from 1 to 3 rising edge is about 36 degrees, and the rising edge phase delay is about 380 degrees. I also turned on the duty cycle over here from the other menus. By the way, you'll notice that the two-channel measurements are in this white, whereas the single-channel measurements are in yellow. So that is all I'm going to do on the Rigol measurements section. Now I'm going to switch over and look at Siglent. When I reviewed the immediately preceding section, I realized that I had misread some of these. For example, I think I said that this was the falling phase. It's actually the rising. This is the falling phase. And I also think I misread the delay from 1 to 3 as 0 microseconds when it's really 3 microseconds. So if any of you caught that, that's a result of trying to read very small numbers on the camera display instead of straight off the oscilloscope. But I'll try to do a little better in the future. Moving to the Siglent for measurements. It has an all-measure function, which, as you see, displays in the upper left-hand corner. It's pretty much the same as the Rigol. 36 measurements, I think, instead of 33, but I didn't see any that were really significant in the differences. The other thing, too, this one and the Rigol both have statistical measurements. So now let's do some cursor measurements, and then we'll finish up with the auto measurement functions. You get into cursor measurements by pressing the cursors button up here. Here you see two cursors on the screen, and you basically switch back and forth between them by pushing the button that is basically the all functions button. So we'll move this cursor. So at any rate, there is the cursors, and you see here that the delta t, the 1 over delta t, which is the frequency, as well as the x1 and x2 values are shown. And in case you're hearing beeps in the background, the difference is that there are actually 3 modes for cursors. One is to move a single cursor and then to move to the next cursor. So it's, if you're on this cursor and you push the button, the universal button once, you move to this cursor. If you push it again, the two cursors are locked and you can move both of them together. So once again, this is the cursor measurement. Hopefully we can get it to focus there and go in on that. And there you see you're reading the delta voltage as well as the absolute x and y values relative to 0. So I'm now going to move on and do the automatic measurements on the Siglent. To get the measure menu, you press the measure button. You then can choose the type, and what happens is a selection screen comes up. In other words, unlike the Rigol where there's a list of different ones down here and you have to scroll around, here you see the ones that are picked right now: voltage peak to peak and period. And if you look down here, the voltage peak to peak and period is shown there. So basically the way you pick them is you scroll, and for example if you want, let's see, what's that one? Vmax, so we'll push that one, and then down here you'll see that Vmax shows up at the bottom. Once again, you can only have 5 active at a time. You can clear as you can on the other. Also, you can do a gate function. When you turn the gate on, you get a couple of cursors. One is cursor A and cursor B. You also can have the relative, that is cursor A to B. If you select that, then the cursors move together. If you select an individual cursor, like cursor B, then you can move that cursor independently. And what this is doing is determining the gate that the automatic measurement is going to use. Voltage max and so on are limited by the cursors, just as they are on the Rigol. Now we're going to do some delay measurements, and what I've done there is, once again, I brought up the type, and then up here you see there's a channel 1 set of measurements. You can select the source, but you also can select channel 1 and channel 2. See if we can get that to focus again. Now you move it off and it might show up a little better. There it is, channel 1 and channel 2. You select it with the selector knob, and then you push it, and now it's doing channel delay between one channel and another. You can do phase, you can do all sorts of different measurements, and here is one place that I think the Siglent may shine a little bit over the Rigol. I'm going to show you down here in the manual, so I think it's a little easier to read. You can do things like the time between the first rising edge and of channel 1 and the first rising edge of channel 2, and then it says of 50 voltage level. I think they mean of the 50% voltage level. Basically what these mean, F means, is it the first or is it the last? And then R is rising and F is falling. So this says first rising to falling. This one says first falling to falling, and so on. There are basically 9 functions you can use, and maybe because I've played around with this one a little more than the Rigol, I really like these measurements, because if you go up here, I'll show you what you do. You, for example, go to this one. It explains, by the way, what it's going to be doing. This is first rising, rising. And you see down here the measurement. First rising, rising from 1 to 2 is 2 microseconds. So the nice thing about it, and by the way, it'll also do a phase measurement. I don't know if I showed you that or not, but right here is a phase measurement from one to the other, which is quite a bit more accurate than the Lissajous figures, at least the way I use them. So I would say that overall the measurement functions of the two scopes are essentially the same, except I like the time or delay measurement, phase delay measurements better in the Siglent, but the Rigol has an interesting feature I didn't show you, which is you can display the history of your measurements. And it's really kind of neat to be able to graph the measurements on the screen. I can't find a history function, or at least not that kind of history function on the Siglent. So what I would say is the delay measurements of the Siglent I think are better than the Rigol, but the Rigol has the additional history function, which I think gives it some advantages as well. So I'm going to end the measurement phase here and move on to the next phase in these videos.